So this is number 26, 1.26. Right here it says use appropriate metric prefixes to write the following measurements without the use of exponents. So since this is times 10 to the negative 10th, we want to find something down here that's close to 10 to the negative 10th, which of course would be the nano. And so we'd want to write it as a nanometer if we could. And so rewriting this, 2.3 times 10 to the negative 10th liters. There is 10 to the 9th right here, 10 to the 9th nanos in a 1 liter right here. So there's 1 times 10 to the 9th small unit in the big unit. So if I was going to express this as nanoliters, I'd put that up there, liters as my unit, say that I want to be in a position where it's going to cancel. And there are 1 times 10 to the 9th nanoliters in 1 liter, because there's always lots of these small units in one of these big units. Multiply the first two numbers, 2.3, and then add the exponents. So 10 to the negative 10 plus 9 would be negative 1. And so then I'd end up with 2.2 times 10 to the negative first, but it says without the use of exponents, and so I'd move it 1 this way because it's negative, so I want the number to be smaller than 1, and so it would be 0.22 nanoliters. Letter B, grams, so this is 10 to the negative 6th, and the thing that's 10 to the negative 6th would be something like a micro, and 10 to the negative 6th in 1 gram right here, or 10 to the 6th in 1 gram. And so rewriting this, I would have 4.7 times 10 to the negative 6th grams, and going to micrograms, put that as my new set of units, and grams in a position where it's going to cancel, and there would be 1 times 10 to the 6th micrograms in 1 grams. Multiply 4.7 times 1, I end up with 4.7. Add the exponents, negative and 6 is 0, so times 10 to the 0 is just 4.7, and this would be micrograms. Letter C. This is 1.8 times 1.85 times 10 to the negative 12th meters. So times 10 to the negative 12th is a pico, so it would probably be best to express it in picometers right here. And so rewriting this is 1.85 times 10 to the negative 12th, and that's in meters. Put meters in a position where it's going to cancel. Picometers is my new set of units, and there are 10 to the 12th of the small unit in one of the big units right here. So 1 times 10 to the 12th picos in 1 meter. So multiply these two numbers together and you end up with 1.85. Add the exponents, negative 12 and 12 adds up to 0. So then we end up with picometers right here. Letter D. 16.7 times 10 to the 6th seconds. 16.7 times 10 to the 6th seconds. So if we want to express something times 10 to the 6th, it would be right up here, and that would be a mega. So we're probably looking at megaseconds. And seconds, of course, is a base unit, and there would be 10 to the 6th of the small unit in the big unit. And so if I was going to go from seconds to megaseconds, I'd put seconds in a position where it's going to cancel. Megaseconds is my new set of units, and there are 1 times 10 to the 6th seconds in 1 megasecond. Now multiply these numbers right here, and so I end up with 16.7, and then subtract these exponents, because when you divide, you subtract exponents. So 6 minus 6 is 0, so it would be 16.7 megaseconds. Then letter E, let's see, we're at 15.7 times 10 to the 3rd grams, and we would probably want to express that in kilograms, because kilograms is 10 to the 3rd, and we have 10 to the 3rd right here. And so the relationship between gram and kilogram is 10 to the 3rd of the small unit and the big unit. So put gram right here and put kilogram right here. And in 1 of the big unit, there would be 1 times 10 to the 3rd of the smaller unit. Multiply these numbers together, you'd get 15.7. And then 3 minus 3 ends up being 0, so it would be 15.7 kilograms. And then letter F, we have 1.34 times 10 to the negative 3rd meters. And to find something that's 10 to the negative 3rd, we'd look right down here. 10 to the negative 3rd would be milli. So there's 10 to the 3rd of the small unit in one of the big units right here. So we'd put meter in a position where it's going to cancel, and we said we were going to go to millimeter, and so there would be 1 times 10 to the third of the milli in one of the meters. So the meters cancel with the meters, add the exponent, adds up to 0, multiply the numbers, and you end up with 1.34 millimeters. Last one, letter G, 1.84 times 10 to the second centimeters. So times 10 to the second would probably mean we'd want it 100 times bigger. So centi to a base unit right here would be 10 to the second, and our base unit we'd be looking at is the meter right here. And so we could relate centimeters to meters. And there's 100, or 10 to the second, 1 times 10 to the second centis in 1 meter. So in one of the big units, there's 1 times 10 to the 2 centimeters. Multiply the first numbers, 1.84. Subtract this exponent and this exponent, and 2 minus 2 is 0. And so we end up with 1.84 meters.